Hello, Mr. Hestrom. For this video, I will be teaching you how to do derivative analysis. What exactly do you want to know?
Well, I don't know anything.
You don't understand anything about derivative analysis?
No, like, what's a derivative?
Well, derivative analysis is the rate of the slope.
How do you even use this in calculus?
Well, first of all, you have to find out where the derivative is positive.
And how do you do that?
Well, the derivative is positive anywhere where the function is increasing. So for example, this function f of x is increasing from negative infinity to negative 1.5, and it's also increasing here from 1.5 to infinity. Understand it now?
Yeah, I understand it a little bit.
Okay, then show me where the derivative is negative.
So it's negative at negative 0.5 to 1.5?
Correct. Why?
Because f of x is decreasing.
Yes.
Yay!
Good job. Okay, so the critical points are something that people find more difficult, but it's not that difficult. It's actually pretty simple. The critical points are anywhere where the tangents are horizontal, so that means that the tangent will have a slope of 0. So basically, it's right here at 1.5 and at negative 1.5. You see, because here's the curve, and it's right here. It has a horizontal, and it's a slope of 0.
I get it.
Okay. So then, here we're going to see where the derivative is increasing. The derivative is increasing where the graph is concave upward. And concavity upward is when it makes like a U shape. So right here you see there's a U shape, and the graph is concave upward from 0 to infinity because it has a concave shape and it's increasing.
Okay.
And then the derivative is decreasing where the graph is concave downward, so it's basically, the opposite. So it's just like an upside down U, and that's right here. So the graph is concave downward from negative infinity to 0.
Oh, okay.
So remember how I told you about the critical points? Well, when you do the derivative of the graph, so basically you're doing like the opposite of the graph, you have to find the critical points and you have to mark them. So our critical points were negative 0.5 and 1.5. And then remember the graph is positive from infinity to negative 1.5, so of course it'll be positive. So and it's also positive from 1.5 to infinity. So it'll be going positive the other direction as well. And then the graph is negative from negative 0.5 to positive 1.5. So you see here that it's negative. And that's how you draw the derivative of the graph. Okay, so that was function analysis. Okay, so now this is the derivative analysis. Okay, so the graph is increasing anywhere that the derivative is positive. So you see that the derivative is positive from negative 1 to 0 and from 2 to infinity. Okay, you understand that?
Yeah.
Okay, so where's the graph decreasing?
From negative infinity to negative 1. Because f prime is negative?
Yes. You're doing very good. We're going to be drawing another graph from this function. So you need to find out where that new graph will be concave upward. And that graph will be concave upward anywhere where this derivative is increasing. So as you can see, the derivative is increasing from negative infinity to negative 1.5 and also from 1.5 to infinity. You got that?
Yeah.
Okay, so where would the new graph be concave downward?
From negative 5 to 1.5?
Why?
Because it's decreasing.
Yeah, exactly. So now the critical values. The critical values is anywhere where the derivative equals 0, so it's kind of like when the derivative crosses the x-axis. So that would be x equals negative 1, x equals 0, and x equals 2.
Okay.
Okay, and then the points of inflection are anywhere from where the derivative is changing from increasing to decreasing or decreasing to increasing. And right here you can see that the derivative is increasing or decreasing. So at negative 1.5, there would be a point of inflection, and there would also be one at 1.5 because the derivative is decreasing to increasing.
Okay, I got that.
So now we're moving on to local maximums and local minimums. So a local minimum is anywhere from a derivative changes from negative to positive. So there will be a local minimum at negative 1. So you can see right here is changing from negative to positive. And then at x equals 2 because it's changing from negative to positive. So where would there be a local maximum at?
Right here.
Why?
Because somewhere where the derivative is changing from positive to negative?
Correct. Okay, so remember when I told you we were going to be drawing a new graph?
Yeah.
So you will be drawing the graph of f of x. So I want to see if you actually learned anything. So can you draw the graph of f of x for me?
Okay. So did I do it right?
Perfect. You got the local maximums and the local minimums. You got the points of inflections correct, and it's perfect.
Yay!
Riley, do you think you can do this?
I don't know. I don't know if I can do this.
You can do this. You need to forget about this and just do this test. I know you can do it.
One day later.
Mr. Lendez, are we ready to take the test?
Yeah, I think so. Okay. I'm done. I mastered derivative analysis. You're welcome.
Whatever happened to predictability? The milkman, the paper boy, evening TV. You miss your old familiar friends, but waiting just around the bend.